Hi, my name is Tim Van Milligan. This is RockSim Live, our weekly RockSim training class, where you can discover those tips and tricks on how to use RockSim better and more efficiently. And we're also going to talk about rockets, so you might learn a thing or two about rockets itself. We are live currently on Facebook. We will record this and replay it on Google. Or actually YouTube, so you can watch it on YouTube later. If you have a question and you're live right now, you can go ahead and type it into the comments field here on Facebook. If you are on YouTube and watching it later, you can do via email. Just send us an email with your question and we'll answer it the next time. In fact, we've got 2 questions that were submitted via email, which I'll get to in just a second. My monitor is over here that I'm kind of viewing and watching the posts as they come in. So if you see me looking off over here, it's not that I'm trying to ignore you. That's where my monitor is. So I want to show you first how you can contact us. So let me bring up my screen. So I've got Roxim running here in the background. Let me open up a new window here, and you can see the Apogee website. So this is the Apogee website. Our address is up here at the top, www.apogeerockets.com. If you would like to download Roxim because you don't have it already, you can go over here on this banner bar. You can click left and right and just get to the one that says RockSim and just click on that, and that will bring you to the RockSim upgrade page, because a lot of people are still in the process of upgrading from version 9 to version 10. But on this page right here, it says there's a free trial download version which you can download. And if you have a question, just go over here to the right side and click on the contact form link, and that will take you to our contact form where you can send in your questions. Okay, so the big news this past week was we released RockSim version 10, 10.2. So this was a bug fix. The reason for this bug fix, whenever there's an issue in the software that causes it to crash, and when it crashes, whatever you're working on is instantly gone. No chance to save it, whatever. So there was 2 crashes that we discovered that had to be fixed. One of them was where if you had a design open and then you opened another design, sometimes it would crash right there. In that case, it's not so bad because you're already trying to open a new design, so assuming you had saved it. But the other crash was if you were in the custom fin editor and you were moving points around on the screen to make custom fins, it would crash there too sometimes. So we had to fix that. And we also went ahead at the same time and we added a couple of new features. And I showed them in the last edition of RockSim Live training. So we are on episode 11 right now. So if you go to episode 10, you'll see those couple of new features. We might see them here as we're playing around with RockSim today. So yeah, I'll show you one real quick. So right now we have RockSim open and you are looking at my screen. So if I add a new custom fin, so if I click on custom fin, it always brings up a database, so I'll just exit out of that. So here is the new custom fin screen. You can't see the bottom of it. It's kind of cut off here. But right below here is the OK button and the cancel button. There's also an export template button. But one of the changes, holy cow, something is wrong here. Oh, I'm in RockSim Pro. So what's going on here? That's RockSim Pro. Let me go to RockSim. Let me open up a design here real quick. Go to my applications, go to my RockSim 10.2 designs, Dynastar, and I'm opening up the Stonebreaker. The Stonebreaker is this rocket right here that I'm holding. I try to have one rocket here just so that I have an example, since you can also see my face as I'm doing this. This is the Stonebreaker, and this is the design right here. So let me go to Design Components and click on the body tube and then click Custom Fins. Okay, this looks much better. So one of the features is now I can scroll, I can change that size. That's why I couldn't figure out is why I couldn't change that size. It's because I was in RoxSim Pro. RoxSim Pro hasn't integrated these new features yet because RoxSim Pro is not out. And so this is the custom fin editor screen. You can see this blue line here is the new custom fin. And if I go to the plan points, and this is where all the changes were made on the plan points. So you can see now there's on Windows, this is really hard to see. On Mac, it's easier because there's a dot. And if you grab the dot, you can resize this screen here, and it makes this screen up here a lot bigger. So as you're moving points around, they're easier to move around. You know, if the screen is too small, it's just a little harder to get that precision. So that was the big change. Also, you can change it this way. You know, these are all your points right here, and as you can see, as I select points, it's changing over here. I'm displaying red points when I'm selecting, and if you've never changed the color, let me show you how to do that. Right up here, there's a Preferences button for this screen, particularly this screen. And then if you go to this tab, the Color and Font Settings tab, this is where you change the color. So right now I have Select Point Color as red. I'll just bring up a color picker. I'll change it to blue and click OK. So now if I click on one of these points, you can see it's now blue instead of red. I just find that the red, when I'm doing these trainings, they're a little bit easier to see for people watching me. So that's why I leave it on red. I've made my cursor a lot bigger than normal. So when you're using RoxSim, your cursor is not going to be this big. I just made it big so that as I'm moving my cursor around on the screen, you can see where I'm pointing to. Okay, no questions. I'm looking over here on Facebook, see if there's any last minute questions. We have Joe Batera here. Hi, Joe, and Joe Noble, the two Joes. Hello, Joe Noble, and we have Gopal Mahato. Where are you from, Gopal? Tell me where you're from. It sounds like you might not be from here. You were the first one to show up this morning. We have 10 people that are currently watching. I don't know who the other 7 are. So go ahead and raise your hand and say, hi, I'm here. That lets me know who's here in the room with me. And if you have a question, you can go ahead and type it. Okay, so RoxSim 10.2 has now been released. If you haven't downloaded it yet, you can go, let me cancel out of this, save changes, no. If you go to the help menu and do a check for updates, it will go to our server and see if there's new updates. For me, it's checking every day as I'm opening it. Currently there are no updates available because I am running 10.2. So if I go to the About RoxSim, it says 10.2 F37. So this is the 37th build of F10.2. So we've been working on 10.2 a long time. We've changed it in-house 37 times. That's what that F37 stands for. It kind of gives us an internal ability to know what version we're on. But for you, it's 10.2.0. And F37 is the latest one. And even in-house, I don't have an F38 yet because we're not working on it. We're working on the next version of RoxSim Pro because that's the next thing on our list. Okay, so I have two questions. They're both from Mike Downs. Let me see, I'll bring up his email here. So I'm going to read what Mike Downs says, because he's going to be watching this on replay. I'm working on a design for the NARC Trek program. I've noticed that when I launch the rocket, the 2D flight profile, that the rocket, as it leaves the launch rod, will look like it will, as it leaves the launch rod, will look like or act like it is unstable. It will shake back and forth along the CG point, or not tumble or circle as it takes an upward flight. So basically what he's saying is, as the rocket's taking off, it's kind of wiggling as it's taking off. This is normal. This is what actually happens in real life as your rocket does take off. So let me go ahead and run a simulation where I can show you what's going on there. Okay, so here's we have the Stonebreaker. I need to load a rocket engine in it, so I'm going to go to prepare for launch. And you can see this icon. This is also something that we changed. We tried to make it so that it's a little bit easy, a little bit more intuitive to what's going on. So we have the bottom of a rocket and with two arrows pointing down to the launch pad. So we're hoping that this is more intuitive. That means that this is preparing for launch. It's in the exact same place as the old button, right next to the launch button. So either way, you're going to find it. So here we're looking at the bottom of the rocket. Right now there's nothing loaded, so if I click on the engine mount tube, when RockSim brings up this screen, it's always looking for the engine mount tubes. And then I click on choose engine, and it brings up a list of all the motors that will fit this engine mount tube. And right now I have them sorted from biggest down to smallest. If I click on that again, it will sort from smallest to biggest. So the smallest 24 millimeter tube in the database is an Estes C11, and we have the Estes D12, and I think I'll select that one. And so then I have to select the delay. I'm going to choose a long delay. I always start long and then back down to a shorter delay. My engine overhang is 0.5 inches. So the overhang, if you're looking at the back end of the rocket, you have the back end of the engine tube. And so how far does the engine hang back from that engine tube? And on this particular rocket, it's a whole inch. But here I have it set at 0.5. Why is this important? Because it affects the center of gravity of the rocket. So that's why we want to know how far the engine is hanging out the back. So I'm going to make it 1 inch. And then I hit OK. So it loaded the engine. And if you look at the screen over here, the engine is hanging out the back 1/2 or 1 inch. So I'm okay there. All right, so now under flight events, we're going to deploy the parachute at maximum ejection delay. I'm going through the simulation just kind of so you know how it's set up. Simulation controls, I always leave that at default. My starting state, so we had, previously I was launching from a rail because it was really long at 98 inches. So I'm going to back that down. On this one, I would probably use a 4-inch rod. So 4 inches is 48 inches, and my launch angle, I'm going to go straight up. Okay, so I'm going to type in 0 under launch angle, and then hit the tab key, and you can see that my selector wheel right here, which controls the launch angle, it snaps right back to 0 right at the top. So we're launching straight up. Under launch conditions, I'm going to back this down to 700 feet. That's kind of my typical. That's kind of like the middle plains of the United States, you know, like Iowa, Illinois, Nebraska, somewhere in the middle of the country, about 700 feet up. This is a standard day, and my breeze, I'm going to change it to a custom speed range. I do this so that my speed is always constant, because if you choose a normal wind condition, like light wind. It has a low wind speed and a high wind speed, so you don't know exactly what the wind speed is as it's blowing past the launch pad. It's somewhere between 3 and 7.9 miles per hour. It's like on a real rocket day, you don't know exactly what the wind speed is when you push the button, unless you actually have an anemometer there and you're looking at it right away, you know, as you're pushing the button. Normally, you're watching your rocket and a gust of wind may come through as you hit the launch button. So there's variability, and that's what we're trying to mimic here in RockSim. But for this case, I want a constant wind speed so that I know exactly what it's blowing. And to set that up, choose custom speed range, and then change both the low wind speed and the high wind speed to the same number. So I typically use 8 miles an hour for both my low wind speed and my high wind speed. Wind turbulence, what wind turbulence is, okay, so if I had a variable wind, like from 3 to 7, my turbulence is, it's going to start at a certain velocity. Maybe it starts at 3 miles an hour, but then a second later, it might be a different number. And then a second later after that, it might be a different number. So it might go from 3 to 4 to 7, you know, like a gust came through. So turbulence is how steady the wind is going to be. So it's not going to jump from 3 to 7. It might jump from 3 to 3.5 to 4, you know, in lower increments. So you're not getting big waves of wind coming through. So when I set the low wind speed and the high wind speed at the same number, this wind turbulence isn't going to do anything. But if it annoys you, you can just say constant wind speed. And you can see the frequency, it changed it to 0. Now wind starts at altitude. I don't think I've covered this before. So sometimes you're on a launch field and maybe there's a row of trees that run down one side of the launch field that's blocking the wind. It's kind of like a windbreak. And so on the ground level, it's a calm wind. But as soon as the rocket would get above that tree line, all of a sudden it's hitting some wind coming through. So that's what the wind starts at altitude is. So you might set it at 50 feet if you have a 50-foot, you know, high trees lining your launch field. But for me, you know, here in Colorado, we don't got a lot of trees because it's a semi-arid desert. So on our launch field, wind starts right at that ground level. Let me check my comments over here. Hope we had a lot of people that checked in. Don Thomas says hi. Dwayne Bailey says hi. John Sislek says, hello, Tim. I downloaded 10.2 this morning. John, you're going to love it. It's fixing those bugs. If you look at our website, we fixed a lot of things. Things that were annoying me. Let me see if I can open up that screen again. So this is our website. And if you go to How-To and Guides and Software, and then you go to the version history, then scroll down to where it says 10.2. And so this is the changes, all the changes that we made in 10.2. So we added 3 new things, 3 new features, things that Roxim didn't do before. And then we fixed, I think I counted them yesterday, there were 17 things that we also fixed. The 2 most important ones were down here at the bottom: crash on exiting the custom fin editor screen, and a crash when switching between rockets. Actually, I covered it earlier. So you can read through all of those. Okay, so let's get back to RoxSim, or let me say hello to everybody that popped in here. Joe Batera says, you downloaded the regular 10 point, so version 10 is the updated version. Yes, Joe, if you download anything from our website, it will be the latest version. So it's no longer 10.0, it's no longer 10.1, it's 10.2. We changed all the links when we did the update. So if you're downloading the trial version or you're downloading the full version, which is actually identical. There's just 2 places on our website to download it from, but they're both downloading the exact same version. So you always have 10.2 if you're watching this today. Bill Lindsay Jr. says, hello from Wichita, Kansas. He says, I wasn't aware of 10.2 until late last night. Well, I know it's slow. The word is getting out slow, but we're trying to get it out. John Sweeney says, hey, greetings from Florida. Awesome. So right now we have 10 people are watching, and now I know who you are. So thank you for raising your hand. I really appreciate it. It's kind of nice to know who I'm talking to, because, you know, right now I am alone in our studio with just the camera. And so, you know, just seeing the monitor that you're here, it gives me comfort. So thank you again for showing up. Okay, so back into Roxim. We've covered our simulation properties, and let's go to flight profile. So flight profile and launch do the same thing. They both run a simulation, but flight profile gives me that 2D profile of what the rocket looks like. So let's look at it here in the 2D flight profile. Okay, let me move this over here so you can see my full screen. Another change that we made in version 10.2, another bug, if you click on the details button down here, previously in 10.1, the units column wasn't showing up. It was just blank. So you just didn't know what your units were. Now those are available. So I don't need to see those. Okay, so here's our rocket sitting down here on the launch pad. And if I click the launch button, the rocket takes off. This rocket's going pretty straight. It's not wiggling very much. So I stopped the simulation, and now I'm going to take the slider bar down here, and this controls my time. And I'm coming back down to as the rocket takes off. So this one is not rocking back and forth very much. But I bet it's rocking a little bit. It's just so slight that you're not noticing it. So let's see if we can see if it actually is rocking back and forth. So that's what the simulation looks like. So if I run it all the way, I'm speeding it along. Rocket goes up over the top, comes down at 7 seconds after burnout. Parachute pops open, and it drifts back down to the ground, and we can see it's going to land 513 feet downrange. Okay, so the wind, you can see we have wind because it's blowing it, to the right on the screen. And you can also see this smoke, this column of smoke, it's drifting with the wind. So that's kind of a visual indication of what is going on as the rocket takes off. So let's click cancel here. Now I want to go to the plots. So this is the plot. So we're going to look at a graph here. And what I want to plot, I'm going to leave altitude there. I'm going to clear out crosswind drag. And what I want to look at, let's leave velocity there. We'll just add, let's see, we'll go wind angle of attack. So as the rocket takes off, it's going to hit a wind angle of attack. So let me get my regular camera here. So the rocket takes off. As it's on the launch rod, it's fixed. So the wind, it doesn't affect it. As soon as it leaves the launch rod, all of a sudden we have that 8-mile-an-hour wind hitting it. And if you do the vector math, so we have the rocket velocity going up, we have a wind coming this way, so we have an actual vector going this way, and we're going to see that, and this is called wind angle of attack. And the rocket is going to want to weathercock into the wind. And it always wants to zero out that wind angle of attack. So eventually, if we run the simulation long enough, it would be going horizontal so that it would have a zero wind angle of attack. But what happens is the rocket, as it's taking off, it hits that wind, and it's kind of like thunking it. And it's thunking actually down here on the fins. You're kicking it hard this way, and the rocket goes into the wind, but then its velocity says, hey, I need to straighten out. So then it will start going back, and then because of its momentum and the angular momentum, momentum is the property of matter that says, this is, Newton's first law, an object in motion is going to continue in motion unless hit by another force. And so that first force knocked it over. And so now it's got motion going this way, and it's got angular momentum, and it's going to rotate too far. And then the wind is going to hit, on the other side, and it's going to bring it back around, but then it's going to bring it around and it's going to rotate too far this way. And that's where that wiggle comes from, is it rocket's trying to straighten itself out. So now we want to look at that here on the graphs. Wind angle of attack. And I'm going to end this. I'm going to end it as the rocket reaches peak velocity, because I want to compress the time on my graph. So I'm going to plot graph. Oop, and it put it off the side of my screen here. Okay. Oop, now it went off to this side. Oops, where'd it go? It's between I got two screens going here. And there it is. I'm trying to make it smaller so you can see it. Oh, you can't see it because I'm on the wrong screen. All this time I'm on the wrong screen. Okay, so I'm on the graphs. Is anybody yelling at me that I'm on the wrong screen? Okay, so here's my graph. So how do I get to the graph? Let me do that again. So we ran the simulation, this last one right here. I'm going to click on the graph button. It's going to bring up this screen, and I selected from my choices wind angle of attack, altitude and velocity, and then my graph ending point when the rocket reaches peak velocity. So this is going to happen fairly short. The other thing I want to change here is this legend position, because I want to get this as big as possible, so I'm going to say no legend. And then hit plot graph. Again, it put it over here on the wrong side of my screen. Okay. I don't want to cover it up. So the legend position, before it said on the right, and so it would have took up all this space here on the right. So the blue line here is the wind angle of attack. So at 0 seconds, the rocket is on the launch pad, and I did altitude. So this orange line is altitude, and you'll notice that as the rocket is ascending up the launch pad, our wind angle of attack is 0 until it reaches the 4 feet. Because remember, we selected a 4-foot long launch rod. At that point, all of a sudden it gets hit with that gust of wind, and our wind angle of attack jumps all the way up to 12.5 degrees, way up here. So now that's, the rocket's, it's now at a 12-degree angle of attack going into the wind. And then as it keeps going up, the green line is our velocity. Our velocity is increasing, up to this high point right here of close to 158 miles an hour, somewhere up here. And that occurs at an altitude of, our altitude right here, 230 something feet. Right there is our maximum speed. But during that time, as it's climbing, you can see our wind angle of attack as it's picking up speed. It's a vector, so as the rocket's going slow and the wind is going fast, as it comes off the launch rod, that vector is very short, because our vertical velocity is maybe this tall and our horizontal velocity is this tall, and so the angle is pretty steep. But as the velocity picks up speed, now that vector gets larger, and that's why this angle is decreasing. But then you can see here's our 0 point right here, bringing it across. So eventually the rocket is now going it's overshooting, and it goes to a negative about 2 degrees right down here at the bottom. And then it starts correcting again, and so you get this oscillation. So as it's coming off the launch rod, picking up speed, you'll see that oscillation, and this one's dying down pretty quick, which is a good thing. So that's what that means. Let's see if we can make it more pronounced by changing the design of the rocket. So if we make the rocket more stable, it's going to correct faster, and because it corrects faster, it's going to overshoot faster. So the first thing I want to do is go to Design Components tab, and let's find those fins, and I'm going to just start deleting them. So I got my strake fins. I'm going to delete those. I'm going to say yes. I'm going to delete that, and you notice that our center of pressure moved back because forward fins make that rocket less stable, and that's the CP. When the rocket is less stable, that CP will be further forward, closer to the center of gravity, which is right there. And now we'll take our fins and let's edit them and make them bigger to move that center of pressure even further back. I don't want to go that way. I want to go this way. Make this screen bigger for you. So you can see our fins down here. So we can make the sweep angle. I'm going to tilt those fins back. You can see the center pressure is moving further back. And I'm also going to change the semi-span. So I'm going to use this slider bar here, but this one's a little tweaky. So what you do is if you just put your cursor on it and now use the arrow keys on your keyboard, you got finer adjustment of that slider bar there. You can see now I'm making my fins taller, and this is making the rocket more stable. And I'm going to do one more thing. Remember I said changing the angular momentum. How do we change? We need to change the inertia of the rocket, because that's, once it's moving, we want it to keep moving. So to change the inertia, inertia is a product of the mass. It's what do they say? Inertia is it's a product of the mass. I'm trying to think of the exact word to say. But we're going to change the mass, and we're going to add mass to the nose cone. So I'm going to put in a mass object in my nose cone. I'm going to cancel out of the database. So right now the mass is at the very tip, and I'm going to slide it back. I'm going to put it right in the middle, and now I'm going to give it some mass. I'm going to probably throw in 60 grams. So now what that does is it moves the center of gravity further forward. Did it move over? Let's make it 100. And watch the center of gravity symbol as I hit the tab key. Didn't move. Oh, yeah, well, that should have moved. So we've got something. So yeah, see, we got mass override turned on. So I'm going to turn that off. So now that center of mass really moved. So that's our center of gravity. Okay, so now we're ready to launch. Let me make that mass less. Now we'll go back down to 60 grams. 100 grams is pretty heavy. Okay, so now our center of gravity is here. Our center of pressure is right here. So when this thing starts rocking, it should move pretty far. So let's go prepare for launch and flight profile again. Okay, so here's our rocket down here, and let's see if it wiggles more than it did before. There it did. Did you see that? Let me back this up. The rocket's coming off the launch rod. You know, see it's wiggling back and forth. That is normal. Let's see, because we added the nose weight, it probably didn't go as high. Let me cancel this. We can see our maximum altitude went down 50 feet from the previous one. And if we look at that graph for this new simulation, you can see, well, let's see what it will look like. You can see we got a lot more wiggling going on as the rocket's stabilizing itself. But there it is. That is why your rocket wiggles as it comes off the launch pad. It's following the laws of physics. That's what Newton says should happen, so I believe him. There you go, Isaac Newton. Okay. We got another question here from Al Anzik. He's a local guy. I know Al personally. What's the process for calculating the delay for an air start on a two-stage rocket using RockSim? Okay, that's a really good question. Let me look at my time here. Take a sip of water. So, let's open up a two-stage rocket. We have a two-stage rocket, the Rip Roar from Dynastar. Do I want to save those changes? No. Okay, so this is the Rip Roar rocket from Apogee Components. Let me show it to you on the website just in case you've never seen it before. So to find a rocket, you just go to the search bar right here and just start typing. And you can see RIP, and just the typing the 3 letters gives me the Rip Roar. And this is what it will look like. Okay, so it's a two-stage rocket. It flies on D motors, 24 millimeter motors. As you can see in my delays here, I have all 24 millimeter motors. So let's select this one. I want to load motors really fast. So I always just find some motors that have been previously run, and I click on it, and then using the mouse button, right click and say load engines, and it immediately loaded the engine. You can't tell unless you look really close down here. You can see there's an engine loaded at the back. If I go to a 2D view, you can see I got 2 engines loaded. So I got a D12.0 and a D12.7. Let's go set our simulation here. Okay, so the boosters, what Al was talking about was the delay between the boosters, the booster stage and the sustainer stage. Right now there is 0 delay. The ejection delay sets that value. So let's run a simulation first and then figure out why you might want to change it, and then kind of figure out a process of is this a good value or not. So he wants to know the process. So under simulation controls, we're launching straight up. My deployment is at maximum ejection delay. Starting state, again, we're going 48-inch launch rod, straight up with an 8-mile-an-hour wind. And we click on flight profile and see what this looks like. So here's our rocket down here. We'll start the simulation. Rocket takes off. You can see that here's our booster stage falling away, and it has red dots where the sustainer has green dots. If you want to change that, let me stop that. You change it right here in the preferences. So if I click on preferences, and if I go to flight track, here's what controls those colors. So my primary flight color is green, my booster is purple, and then if I had a second booster on here, it would be yellow. And my colors for my grid down here, that is under the rulers tab. So right now I have yellow and a font of Arial. So if yours are different, This is why I changed my preferences. So I'll click OK, and it just re-renders this. Okay, so now rocket takes off. Okay, so here, when you see that first red dot or the purple dot right here, that means my booster has already fallen off. It's obscured by the smoke, so it's actually right there. I can just barely see it. It's obscured by the smoke of the sustainer motor. And now you can see it more clearly right here. The rocket takes off, and you'll notice that it popped its parachute way out here. So, first criteria, Al, is the rocket going up? And our criteria is we define it by these dashed lines right here. This is what we call the weathercocking cone. We want the peak altitude of our rocket to stay inside that cone. Right now, our peak altitude is right here, which is outside of the cone. So we've already got one problem right there. Now we're going to add a delay to this, and you'll see what actually happens. And I'll give it away right here, is the situation is going to get worse. As the rocket takes off, it's going to be slowing down, the wind is going to be hitting it, and it's going to be arcing further into the wind. So right now, if I look down here, it's about 500 feet, 500 and some odd feet. Well, I can go right here. So if I look at my range, 544 feet upwind. So let me cancel that, and we're going to go back, and now we're going to add a delay right here. So I'm going to click on the down arrow, and I'll just choose a 3-second delay. See what happens. Okay, so the only thing I'm changing is the delay between the booster stage burning out and igniting the upper stage. Hit the flight profile. Oh, look at this. Our rocket is way over here off to the right side this time. So that kind of gives you an indication that it's going to be going even further. So before we were at 544 feet, which was about here, was our peak altitude. So now when we run the simulation, the rocket is taking off. It's coasting. You can see the booster is still attached. So is this a safe flight? I hope you would say no. In fact, this one, it's ejecting on the ground. The parachute's not even coming out. And you can see over here on the summary screen, we got the icon that said this rocket crashed. So obviously, under these launch conditions, we do not want the rocket to do a delay. So let's change our launch conditions here. So let's go to a 0 mile an hour wind. So that's all we're changing, 0 miles an hour. And let's go back to that first one where it's a 0-second delay. And now let's run the flight. Rocket's taking off. So it's down, straight down here. Rocket takes off. Since there's no wind, it's going nice and straight. And it's going straight up, and our booster is falling straight down. It's obscured here with the smoke. Parachute pops out right there at Apogee. Okay, let me kind of slow that down again. So the rocket takes off. Takes off. You see, oops, I went too fast. See the booster coming through the smoke there? And it's falling straight down. Okay, so now this flight is perfectly fine under these conditions. No wind, everything's going straight. Okay, so now we got 1,193 feet, almost 1,194. So now let's put a delay in there and see what happens. So again, we're going to go put a delay in there, and then hit flight profile. Rocket's down here again, takes off. You can see the booster stage stayed attached. At this point, it kicks it off, and the rocket takes off again. And it's coasting upwards, keeps going. Okay, and then it comes right straight back down. So let's go back over here. So our altitude here is we lost altitude. I was thinking that we should have gained a little bit of altitude, but we actually lost altitude. So if you were trying to go higher for this particular delay, I wouldn't choose it. But we can go back here into RoxSim and we can choose a custom delay. Okay, I'm going to change, I'll do a custom delay real quick. So I'm going to change this to 1 second. Use 1 second delay. Let's go launch that one more time. Okay, I'm sneaking a peek over down here. I'm looking at my altitude. So we still lost altitude with that delay in there. Okay, the trajectory looks the same. So what's going on here is the rocket, as it's coasting upward, it's carrying the mass of that booster stage. And that's kind of stupid, right? We want to drop that booster off and then coast upwards. So let's do that. So to do that, we're going to change this back to a 0. So immediately after burnout of the booster stage, it falls off. And now, now we want to delay the ignition of our upper stage. And so that's where ignition delay comes in. So I'm going to delay the ignition 3 seconds because that's what we did before. I'm going to type that in and then hit the tab key on your keyboard. Always hit that tab key so that it accepts the value. So now we're going to drop the booster stage, coast 3 seconds, and then ignite our upper stage. This is called air starting because we're air starting the motor up in the air. And to do this in real life, you have to use electronics. And you're going to probably want to use something like the simple timer. So if you go to the Apogee website, go to the search bar, type in simple timer here. And there's our simple timer. And the simple timer, this is what it looks like, but you have to set this up in your rocket. And what you get is, you see there's no smoke right below the rocket. That means that it was coasting. There was no smoke, it dropped its booster, and then up in the air, it fired its motor, and you're going to get something that looks like that. It's so cool to see. I love air starting. To set that up, you have to do the ignition delay right here. And then we're just going to do flight profile. So the rocket's going straight up, remember, no wind. So we're going to click launch, rocket's taking off, drop the booster's already fallen. And there it is. Hey, wait a minute, something happened. It should have dropped it earlier than that. Let me go back here, make sure I set this up right. Ignition delay. My ignition delay didn't ignition delay. Let's make it 4 seconds. Flight profile. Okay, this looks better. Something changed. It didn't accept that 3 seconds there for a second. Okay, so the booster, there it is. It's fallen away. And then it dropped. But you see the rocket, it slowed down. And because it's slowing down, wait a minute. It's just arcing over due to gravity because we have no wind. So see, the smoke, it just hung there in the air. So this is not a good trajectory either. I just backed it up really quick. Okay, so now we want to go. Let me cancel out of that. As you see, this is the nomenclature here. We had a D12-7, and then the -4 means that it delayed for 4 seconds. So let me change that number again. Let's go to 2 seconds. Okay, flight events. Okay, we're still ejecting at maximum ejection delay. Yeah, that one worked. I think. It just looks like the booster is not falling off at the right spot. Okay. All right, so Let me look at the chart right here. I want to look at the mass. So now I'm plotting mass, altitude, velocity, mass. Let's plot this, and we want to end this at the end of the data. Plot the graph. Okay, so I'm looking here, and I want to zoom in. Okay, so the mass starts out high, it burns, hits a constant, and then it burns again. It's like the booster did not fall off at the right time. Should have fallen off at the right time. Okay, so I think that gives you a little bit of the process there. I have to explore this, why this is not falling off correctly. Look at it one more time. That's going to be the same. Cancel. All right. So, but that's the kind of the process, Al, is you're going to adjust that ignition delay and look at that flight profile and see if the rocket is still going on the trajectory you want. As long as it's safe, you can adjust that delay. But again, it depends on the wind conditions. I got a couple more questions, so I want to get to these right here. So I hope that's answers the question, Al. Hello from Nebraska, says Jeff Miracle. I'll have to back up and watch this, but I wanted to say, yes, I'm watching. I can't always catch this as it is starting. Okay, that's fine. Last Dignit from, he's from India. He says, last week I asked the question about optimum weight and rocket stability, but my understanding is a little wrong. My actual question is, how can I calculate the exact nose cone weight with the help of Roxim so my rocket goes as straight in the sky? So we kind of talked about that earlier, Dignit, as we were talking about moment of inertia and angular momentum as the rocket's wiggling like that. You want to keep the center of gravity and the center of pressure close together so that you don't get a lot of wiggle, because if it's wiggling around, you're losing altitude. Anytime the rocket's not going straight, you got excess drag. So if you want to go as straight as possible, well, one, launch on a day when there's no wind. We saw that. And then two, go fast, because the faster you go, the taller the vector as the rocket comes off the rod, the straighter it's going to go. So it's not so much the weight, except for when there is weight, you want to keep the weight low, and you want to keep the distance between the center of pressure and the center of gravity as close together as possible so that it will go straight. This is a common question we get in TARC. How do I keep my rocket going straight? And then another tactic that you can use is to spin the rocket. Spinning the rocket will keep it going straighter. And this will also help Al with his question on delayed staging. And if I have time, I'll open up Roxim Pro and show you delayed staging in Roxim Pro, what that looks like. So hopefully that answers your question, Dignit. New question I have, Roxim 10, and I want to update to 10.2, but don't have any updates from Roxim. What should I do? So what you can do, Dignit, is just download the free trial version, because that's 10.2, and then just install that, and now you have the latest. So go to our website, install 10.2. Al says thanks. Okay, so that answers Al's question. I'm going to open up Roxim Pro and show you, Al, in Roxim Pro what this would look like. That was the Rip Roar rocket. So Rip Roar. So now I'm in Roxim Pro. Where the difference is in the 2D flight profile is now a 3D flight profile. So let's go to flight simulations, load our motors again, load engines. I'm doing this really quick because we got like 5 minutes left. I don't want to keep you longer than I have to. So the motors are loaded. And I'm going to go prepare for launch. So you can see the motors are loaded. I'm going to do an ignition delay here on the upper stage. I'll do 3 seconds. And then under flight events, in RockSim Pro, we also control, we can control when staging occurs. And right now I'm going to say maximum ejection delay. So that means at 0 seconds from the booster motor, because it's a D12-0, that booster motor will eject and stage the rocket. That starts the timing on the upper stage. And our parachute deploy at maximum ejection delay. Starting state, let's go back to 48-inch launch rod. I want to go straight up. Launch guide. Azimuth is a compass direction. So if we're going straight up, the compass direction doesn't matter. So north is straight up. East would be 90 degrees, south 180. West would be, minus 90 or 270. So I'll just go north. Simulation controls, I'll leave that alone. Launch condition. This is our launch site. I'm not sure where this location is. We'll find out real quick here. Under wind, we have a 8-mile-an-hour wind coming out of the east, or coming out of the west, coming from the 270 direction. So that's coming from the west. Let's run that flight profile. So this is what RockSim Pro will look like, and I'm kind of teasing it again. Right now it's got to run the simulation and then it has to go fetch the maps. That's why it's taking a little bit longer here. Come on, wake up. There we go. So this is the Earth. It's bringing up the maps. And I had the question, my other question from Mike Downs was, he was concerned about RockSim Pro and our future version of RockSim, which we call the Launch Visualizer, will be in a web browser, which means you need to be connected to the internet. And his concern was, what if you're at a launch site and you don't have internet connection? Well, as of today, March 26, 2021, you can now go out and buy a Starlink internet connection so that anywhere in the planet you can connect to the internet. And this is not the only service for, well, they call this broadband internet. Broadband internet is just high-speed internet. So it comes, and then you need a Wi-Fi signal to get to your computer. So you can get Wi-Fi on your launch field today, right now, today. If your launch site doesn't have it today, what I would recommend is, if you're a member of a local club, bring it up in the next meeting and say, hey, let's, as a group, purchase internet service for our field. It might not be Starlink, it might be your local cable provider, it might be like Verizon and 5G cell phone service. Starlink is not the only internet provider that's putting up satellites. Jeff Bezos from Amazon, Jeff Bezos and Elon Musk are having a contest right now who can put up their broadband internet satellites faster. Right now, Elon Musk is winning. This month alone, March of 2021, already he's launched 4 rockets with over 240 satellites added to his constellation so that he can cover the world faster. So in the future, Mike, it's not going to be a problem. internet's going to be all over, and if you have a cell phone, you can create a Wi-Fi hotspot, and so you can connect your computer to your phone to the internet. But in the future, you'll just have Wi-Fi on the field, no matter where the field is, unless you're on the moon. We don't have Wi-Fi on the moon yet, but as of today, we do have it. So don't worry about internet service in the future. I know it's coming. That's why I'm racing there as fast as I can, because people are going to want this on the field. And so we're trying to get this, because right now, when Roxim Pro is available, we'll have that. Okay, so here's our rip roar rocket sitting on the launch pad. I'm going to back out. I'm zooming out. Okay, so I'm trying to figure out where I am, and now I understand where I am. I am at the Great Meadows launch site where the TARC finals are held every year. This is in Virginia, outside of Washington, D.C. So that's what the field looks like, and this little red dot right there by my mouse is the launch pad sitting on the ground. Let me angle it a little bit so we can kind of look at it from the side. And let's launch it. Well, okay, it's going to recenter in the middle. Let's launch the rocket. Rocket's taking off. It dropped the booster. The booster is coasting upwards. And then the rocket takes off that way. Okay, so let me pause that right there. This screen right here is just showing the rocket. Right now it's under a parachute. Oops, I'm moving that the wrong direction. So this little screen right here is this button. So I'm going to turn that off. This one up here controls our preferences. And what I want to turn on is the weathercocking cone, because right now it's turned off. So in RockSim, it was 2 black lines. In RoxIm Pro, it's actually a cone. And we can see the red dot, and you can kind of see the cone. But this red dot, if it was a green dot, it tells me that the apogee point is inside the cone. Because it's a red dot, it's telling me it's outside of the cone. So I have to move it around so I can see. So here's my cone, and my red dot is on the outside of the cone. So for this rocket, it's staged down right here, and it coasted upwards for 3 seconds. And then the wind caught it, and it arced into the wind. Now this rip roar rocket is a very short rocket, and its center of gravity and center of pressure are really close together. So it's not a highly stable rocket. If it was highly stable, it would arc into the wind more. But because this is not a highly stable rocket, it almost made it as a good rocket. Let me go here to this view. This view kind of centers things a little bit better so I can see things. And I'm zooming in, because what's interesting to me is down here, what's going on down here. So I'm going to take my slider bar, back this up a little bit. So my rocket's way up here. It's just so small you can't see it. You can see it at that point is when it started staging. Let me zoom in a little bit closer here. So the rocket is way up here. Let me click this button. This will find the rocket. Find the rocket. So you can see the rocket is staged right at this point. Let me back out. Our booster stage is right up here. See, it's falling away, and the booster stage is actually gliding. You can see a normal booster stage would just tumble straight back down to the ground. But something happened to this one. This one's actually gliding, and it's gliding in reverse, which is really cool, because that's kind of typical of boosters that fall away. They kind of glide sometimes. So the staging point was when the yellow line first appears, and I'm kind of zooming in on it, and I would say that it's somewhere right about right there is where it's staged. So if I move this back. Okay, so you can see the rocket is hanging on right here. And then it dropped away, so it's separated now. The rocket's taking off, and I gotta zoom out You can see my sustainer is right up here, and it's coasting, and it's going to coast for 3 seconds. And the wind is kind of pushing it backwards. So the wind is coming out of the east, so or the west. So right now, north is the black pointer right here. So north is this way, and then west would be this way. So the wind is pushing it this way, and you can kind of see it's kind of drifting backwards. Zoom out a little bit more. And then at that point, you know, we air started and the rocket took off, which was really cool. So this is Roxim Pro, and this is what for Al's question about air starting, this would be ideal for that. The other thing, Al, is we talked about spinning the rocket. You can do that in Roxim Pro. So let me cancel out of this. So remember that trajectory we just saw. Let me go back here. Under starting state, I'm going to give it a roll rate. So starting roll rate right now was 0 degrees per second. So I'm going to give it a one rotation per second rotation. So it's 360 degrees per second. So that will give me 1 revolution per second. And let's run that same flight profile. And remember what the first trajectory looked like, and now we're going to look at the second trajectory. See what it looks like compared to what that first one looked like. Remember, the first time our apogee point was outside the cone. Can we get the apogee point inside the cone by spinning the rocket? That's what I think we can do, and that's what I'm hoping that will show up here. This will be our last simulation because we are now past time. Let me see if there's any other questions here at the last second. Oh boy, we got somebody from Australia. Alan Lone Rider from Australia. Good day, mate. That's my best Australian. Okay, so here is the rocket sitting on the launch pad. Let's launch it. Rocket takes off. It's still in the cone. Oh, look at that. It's taking off. Oh, see, the green dot. Green dot is good. It wasn't a red dot. Let me stop this here and back out. Let me change views. So now, see our weathercocking cone? So this flight, I would call safe because the rocket stayed within the cone, and we did delay staging so that we can get some extra altitude. Now, did the rocket actually spin? So we want to go back down here. Let me turn off the smoke. So I'm going to go to the preferences, and I'm going to turn off the smoke. So we can watch the rocket down here. And what I want you to watch for is the spin of the rocket as it's coming off the pad. Now, all we did was spin it coming off the pad. We gave it an initial spin. In real life, to do that, you would need a turntable of some sort or a launch tower that had rails that were curved. So as the rocket comes out, it has a spin coming out. And there are launch towers like this. The other way you could do it is canting the fins so that it causes the rocket to spin. But if you cant the fins, now you're adding extra drag. So ideally, you want to spin it on its own before it's coming out of the tower. So as the rocket takes off, you can see it's rotating. If you look right here real close, I'm pointing with my finger at my computer like you can actually see that. I got to use the pointer on the mouse. So the rocket's coming off. It is spinning. Let me zoom in here. Center it. So let's see if we can zoom out just a little bit. Too far. So the rocket's taking off. Yeah, and it just went out of the view. Yeah, but you watch this view down here, you can see that the rocket is actually spinning a little bit, but its spin rate is slowing down just because of drag. It just doesn't, if you cause it to spin and you wanted to keep it spinning, what you would do is increase the angular momentum by increasing the angular, not increasing the angular momentum, increasing the angular inertia. And to do that, you would probably put weights on the tips of the fins, so you get more rotational inertia here, and that would cause it to keep spinning. So you can go, add, more delay between the stages. So I've gone really long right here today, but I want to I want to reward you. So if you're still here, raise your hand one more time. And it still says we have 13 people here. So if you raise your hand one more time and say, hey, I'm here, go ahead and do it. First person that does it, I'll give you a X15 poster like you see back here on my wall. So you see this poster right here, the first one that raises their hand. And it was Dwayne Bailey. Dwayne Bailey, thank you, Dwayne. You get the poster. It pays to be here and watching live. If you're watching this on replay, come next time. We really want you. We'd love to see your questions, answer your questions. Ronald Zacher says, I'm here too. Cool. Ronald is kind of a regular also. So that's our RockSim Live for today. I really appreciate you coming. I got to find my button over here because I'm going to end the video here. But remember to come back to the Apogee website. Our address is on the screen, apogeerockets.com. That's where you can find RockSim. RockSim Pro is not available yet. It's coming soon. I don't know when soon is. But as you saw, it is working just fine. But we do have some finishing touches we need to put onto it. We got to put all those fixes that we put into RockSim 10.2 into RockSim Pro. And RockSim Pro is actually going to be a subscription service because it actually runs the visualizer part, that 2D or that 3D flight profile that runs off of our server. So we got to cover the cost of our server. So it's actually going to be a subscription service. So I've talked about that before. I've been teasing it, and it's coming. Lots of good stuff coming. So thank you for watching, and we'll see you the next time. And I'm going to end this video in 5, 4, 3, 2, 1.